Hello and welcome to this session. In this session, we are going to talk with Jaime Gonzalez, CTO of Pentasoft. Pentasoft is a company that they are doing a lot of event-driven architectures, and they will show us what kind of patterns they are implementing and how they are doing it in their everyday. So, welcome, Jaime. How are you doing?
Fine, thank you, Marcia.
Can you tell us briefly what Pentasoft is and what you're doing?
Sure, Pentasoft is a software development company focused on developing software as a service solutions on AWS.
Yes, and what kind of services you are providing?
Mostly, they are, as I said, software as a service solutions for the industrial IoT sector.
Yes. And how long have you been working with AWS?
Well, let me show you my screen in order to see that we started in 2008 in the on-premise world. And we try to implement some set services for big customers, but we quickly find that we weren't able to deal with huge amounts of data. So we started to look for online services and we discovered the AWS cloud. At the moment, we were using S3 on the AWS cloud. And as time went by, we discovered many interesting services regarding event-driven architectures as SNS, SQS, and nowadays we are using almost 40 different AWS services, mostly focused on the IoT world and the event-driven architecture patterns.
Good. So maybe we can start a little bit on how Pentasoft is doing event-driven architectures. Can you show us a little bit on what you're doing?
Sure. Let me show you this product we have. It's called Neuron. It's a software as a service solution for monitoring industrial platforms. Here you can see that we have a multi-tenant approach. This approach is based on an organizational units then inside of AWS organizations platform, and we have a master account where we deal with the creation and management of end user customers, where each of them has a different AWS account where they can deploy their own services and use Neuron as an integrated service inside their own AWS account. For that, we use Amazon EventBridge, that is the connector between this master account and every different AWS customer account.
Yes. So basically, every customer will go into your platform, will create in their own account, like or they will go into and create in an individual account their cloud, and they will connect to this master account. And is everything in the same region? How it works?
No, the idea is to offer our end customers with a flexible and scalable solution. For that, they ask usually us, can we deploy this solution in our account in the region of Asia? And we say, of course, because what we offer is this cross-account, cross-region platform in order for them to have their different accounts in different regions if they want, and in different accounts inside of AWS. For that, what we do is just use the great feature of EventBridge called cross-account, cross-region that allows us to send messages and receive messages from these different accounts, even if the accounts are located in a different region than our master account. So it's very useful, very flexible, and very important for taking into account when you deploy your event-driven architectures.
Can you give us some examples of what kind of things the customers and you are doing with the customer's account with this event bus?
Yes, well, in case that you don't have a billing, for example, set up for the account, what we do is just to allow the end user in one customer's account to create a billing statement. For that, the only thing the customer has to do is to publish a message in this event, and we are subscribed to the same bus, and we are just waiting for one event of those kind to arrive in order to create the infrastructure in order to do the charges by the end of the month. In the same way, we can deal with the device repository. When one customer connects a new sensor in their account, what we do is just listen to that subscription, and what we do is just send them or publish the device repository information for that specific sensor. As the user is creating a new sensor, he subscribes to that information, and when he can see that in the bus, can create effectively the sensor itself. So we have this repository in the master account serving all the accounts of our customers worldwide.
And is this the same event bus that the customers will use internally for their own uses?
No, in fact, we use different buses. In this case, are EventBridge, both of them. Let me change to, we are talking about this account. Let me go into that account architecture. Is this one? It's called Neuron Cloud. In this case, this is the customer account. For these accounts, what we use is an internal EventBridge bus. This EventBridge bus is in charge of dealing with the communication between different microservices inside the customer's account. In this case, for example, when the customer creates a device, he can subscribe to an alarm and says, well, when that sensor goes over the threshold of 20 degrees, please trigger an alarm because I want to know that this event is happening. So in this case, we use EventBridge for communicating both microservices. The same happens with profiling, security, configuration, and so on and so forth.
Yeah, and what are the main benefits that you see of using EventBridge in your different architectures?
Well, the first and most important for us is the cost for the end user. Why is this cost effective is the question here. Because we just send the messages, or we put in the bus the messages intended to be subscribed and read by different services. And with the filtering option that we have on EventBridge, we are able to streamline the consumption of events and the consumption of bandwidth. So in the end, what we have is a very, very lightweight communication between these services, or among them, to be more precise. And secondly, we are able to scale at a very, very high speed, because if we need to include a new microservice, we don't need to change anything of the existing infrastructure. So we are flexible, scalable, and cost effective. That would be the three most important features of this architecture.
Yeah, and I know you're using event-driven in different parts of your applications. Can you show us different patterns that you're using?
Sure. Let me change to another solution that we offer. It's called Acron. Acron is an IoT platform too, but it's intended for oil and gas industry. In this case, the objective is to connect to a gas station network and read data real time from the dispensers and price polls and all the devices running in a gas station, and connect that with the cloud. We do that with a real-time platform based on IoT Core and the family, for example, IoT Shadow, IoT Greengrass, and so on. Here, let me go to a special section. I don't know if you can identify here a clear pattern. It's very, very clear. You are laughing because this is the typical funnel pattern. In this case, what we do is just to create an SNS topic, and from that topic, we subscribe different queues, in this case, SQs. And as you can see, with this topic, we create a fan out. This fan out feeds the importer queue, the materializer queue, the publisher queue, and the monitor queue. All of them are different services intended for different options. But as you can see, the architecture is the same. We subscribe all these queues to that topic messages, and we process all the data. And through the business logic implemented in different lambdas, we are able to deal with different stores. So the fan out is the natural and effective way of creating event-driven architectures.
Yeah, and here you're also using this database service pattern as well. Can you share a little bit more about that?
Sure, it's a very useful pattern. The goal of this pattern is to take advantage of the good features of some storage platforms and the not so good, and avoid the not so good features of some database-based platforms. So in this case, if you are dealing with huge amounts of data, maybe it's very simple to store data on S3. But maybe it's not a good idea to, if you want to aggregate data, to store all the data on S3. So what we do is to update data on one store and read data from a different store that had previously synchronized. With that approach, we are able to deal with both problems from the most effective cost point of view in both of them. When we want to store quickly, we use S3. When we want to read or to do aggregations quickly, we use MySQL. And when we use to subscribe to certain events, we use DynamoDB, as you can see here. And this can go forever with different stores.
Yeah, so basically using the right database for your problem. As
But
we always say in AWS, why we have 16 different types of databases?
because of
So
this,
exactly. Yeah, so what other patterns you have there?
definitely other patterns. Let me just have a look to this one. This module called data materialization is in charge of persisting all the important data in an structured repository, as you can see here. Well, what we do here is to take advantage of an interesting, again, you can see this pattern of something related to kind of fan out, and we use a collection of SQS in order to store data on S3, on MySQL for feeding an external ERP database, but at the same time we store all the information in events. So what we are able to do is to repeat this process of storing data in different with different structures using a different approach. So this materialization is what we later will use for another pattern that we'll see, and in this case, this could be along with the event sourcing, this could be another case of what we call CQRS, a weird name, a weird acronym standing for Command Query Responsibility Segregation. That trying to describe it more simply is, well, if you have to do a command, let's say an update, and you have to do a query, let's say a read, why are you using the same store or the same architecture for that? The optimal solution for this is, well, why don't we use a repository, especially for the update command part, and a different one specialized on read, the query part? And that's the pattern here. We can use external, let's say, reading, and internal, let's say, writing. And that's important because CQRS is alongside with fan out and event sourcing, the three main pillars for event-driven architecture, at least in our implementation of that architecture.
Yeah, this is really good. Can you go a little bit over the benefits that this type of pattern provides you?
Yes, the idea is, give, again, a cost-effective approach to the end users, but at the same time, we are committed with the speed option for the platform. I mean, we offer our end users response times below 1 second, no matter what API they are invoking or what interface they are using. So for that, we need to have a very fast and specialized reading platform and a very concurrent and specialized too writing platform. So the idea is we are able to scale, we are able to do it in parallel, we are able to do it securely, and we are able to do it in a cost-effective way. Those would be the most important benefits, in my opinion.
Yeah, and how you manage the consistency of the data in the two different stores?
So the idea is we have a different approach. We can go to event sourcing, a different pattern again. Let me just zoom in here. In this case, for example, we need to offer to end users the pricing of their competition, in the sense of this is remember for oil and gas industry, and oil prices are in the heights lately. So the idea is to pay close attention to our competition pricing. For that, we take advantage of the information provided by the Spanish government in order they offer publicly the public pricing for every gas station. We keep that data in a on an S3 bucket, and we deal with that data, storing that data in an S3, and we should trigger this topic on SNS for dealing with the alarm notification for our customers in order to tell them, well, take take care of the price because your competition has just changed the fuel from this price to this lower price. So this is
So
the idea.
basically, the customer subscribe to, I don't know, I want to follow all the gas stations that are in my neighborhood, and whenever they change the price, they will receive an alarm.
That's the idea. So the idea is subscription, publication again. So you can imagine the boost is behind that, and so on and so forth. Again, an important pattern, and in this case, even more because we are able to reproduce the price at every price change is stored and recorded. So we are able to reproduce that or to replay that price at the very time that you want. And that's called event sourcing. The idea is to store all the minor small changes to some feature or some attribute, in this case pricing, and we are able to go to have information for analytics, for auditing, for many other things. And that's another
So
important pattern
here,
for dealing with this.
So here you don't have a database where you will be storing and basically updating or creating a historical ledger with all the updates, but you keep everything in S3 and every event is registered there. And whenever you need to replay them, you just replay individually the events.
Exactly like that. Our fantastic S3 is capable of this and even more. But yes, that's the idea.
So what are the main benefits of having this type of solution?
Well, as you can see, is again price is very important because when you have to store huge amounts of data, if you have to pay by the hour that you usually have to do with these relational databases, is going to be a huge invoice. What we are betting on is, well, why don't we store data on a very affordable and really durable store like S3? And if we need something, let's say, more agile in the sense of triggering events on a more precisely way, we take advantage of DynamoDB triggers with streams and so on and so forth. So just combining specialized storage systems, we are able to provide a fast, scalable, secure, and cost-effective service,
Yeah.
in this
In
case,
this
for pricing.
in this case, you have the events stored in S3, but in Dynamo, you have your customers, what they are subscribed to.
Perfect. That's the idea. The idea is data on S3, but subscriptions on DynamoDB.
Yeah, so that's super cool. So in general, I can see that you are using SQS, SNS, EventBridge, basically all the event sources, S3, Dynamo, everywhere. So it would be great to have a general view of what benefits you have seen using these event-driven architectures.
I like to group them in three great blocks. First, from the business point of view, when we get this, we talk about cost all the time, and because I think really is the most important one, but cost
It's very important.
is very important. Most of the time is the blocking part of the project. So cost is an important one, but agility is very important too because customers don't want to wait a long time for getting a feature, and we are very agile with these architectures. Revenue for them are important. Those two factors, and if we are able to reduce costs and to improve agility, we are impacting revenue too. And well, the customer experience, as I told you before, we are offering under a second response times, and that's very important for them too. The second point of view would be the operational. From the operational point of view, scalability is a key point because most of the time they need to onboard a new gas station, in this case, in a very short period. We are able to do that with no effort because the only thing we have to do is no provision needed, no anything. We are on AWS. We are 100% AWS, so we don't need to do anything extra. It's just out of the box. The only thing we have to do is just onboard new customers, and it's very important for them. Resiliency is another request from them, and obviously all the services you've seen here are serverless. So resiliency is one of the key points for them too, and the integration with third-party systems is important. And in this case, again, through API gateway and asynchronous connections, we are able to provide seamless integration with third-party tools. And last but not least, the developer's point of view is important because for us, flexibility is what our developers get most of the time, because we need to change or to increase the services we offer. The only thing we have to do is just to engage with the correct bus and to subscribe and publish the events that we need to consume or to publish to other components of the bus. So that's important. And testing and debugging, we've seen a lot of improvements on that area too. And ending with the productivity, we've seen on all the team members, they really love this architecture for that. They feel productive most of the time.
Yeah, I think after you learn how to use these services, it's quite hard to go back to the old ones.
Definitely, no one wants to deal with transactions and dealing with it's point in time backups of my. No way.
Yeah, but I think for a SaaS provider as you, like prices, and that's super important because at the end you're pushing that cost to your customers. So you need to be competitive. Resiliency, you're providing service to customers. You want to be always up and you want to make sure that everything is working. And then, well, in your operations, you want to sleep at night.
That's it. That's the important thing. But
Yeah.
yes, that's true.
So that's great. So thank you very much, Jaime, for sharing with us different patterns that you're using in Pentasoft and how you're using event-driven architectures to make your business more smooth. And thank you very much.
Thank you, Marcia.
Have a good
Good
day.
day. Bye bye.
Bye.